Hi guys, welcome back to another review guide, second last one of the year for Chapter 10B, Chapter 10B Individual Test. This one should be interesting as I just got home, so the cats are already messing some things up here to start out. You see I'm on a box once again on my coffee table, and boy does Randy love this box. So this one should be interesting, but I'm excited. Not because I love probability in this unit, but I got 3 new pens. All right, I've got 3 new pens I'm going to be using with a nice comfortable grip to them. All right, so I've got purple, blue, and pink. I think I'm going to start out with blue on this first one. Okay, so let's get started. The small state of Euphoria recently decided to use 3 letters for car license purpose plates, but they decided not to use A, E, I, O, U, or Y to avoid making words. They also decided to use only odd digits. So each plate would have to have 3 letters and 3 numbers, chosen from 1, 3, 5, 7, or 9. The number of cars in Euphoria is about 500,000, and they need to know if they'll have enough plates. So your first instinct might be to use a permutation or a combination on this one, but this is actually just a normal decision chart problem. So I have 26 letters. I'm losing 6 of those, so we should have 20 letters to choose from. And I have 1, 2, 3, 4, 5 numbers to choose from. Okay, since in this first one we can repeat letters, I've got 20 of those for my first letter, and since I'm going to have 20 for each possible letter, it's going to be 20 to the third because I'm going to need 3 of those times my 5 numbers, which I also need 3 of. So if you wanted to put this into a decision chart, it would look something like this, right? I have 20 options, 20, 20, 5, 5, 5. All right, those are my decisions that I have to make, and those are the amount of options I have. If you multiply all of these together, or do 20 to the third times 5 to the third, you end up getting 1 million. 1 million options. Okay, but let's take a look at B. What if we cannot repeat? So a little bit changes this time. We can use the same kind of decision chart. Here's my 3 letters. Here's my 3 numbers. This time I have 20 options for that first letter. But now since I can't repeat, I only have 19, and then again 18. And then the same idea goes for the numbers. So I have 5 for my first, 4, and then 3, because I can't repeat. If I use a letter once, I cannot use it again. So multiplying these, we end up getting 410,400 options. So what should we do? Well, we need enough for 500,000 people. So I would say that first option would be the best. So let's do allow with repeats. We need at least 500,000, and that's what that gets us. All right, if we pick B, we're not going to quite get enough. All right, on to number 2. This problem has been coming up quite a bit as of late. A pretty easy solution to this one, if you know what you're doing. If AE is 4, ED is x plus 1, EC is 6, BE x minus 2. All right, pretty simple. You just take one part. You take the 2 parts of each chord. So one of my chords is AD right here. If I take both of those parts and multiply them with each other, so 4 times x plus 1, I see a common misconception where you add the 2 of them. You need to multiply them. So you're going to have this distributive property thing coming up every single time. Set this equal to the other chord, so 6 times x plus 2. Just really follow your with your pencil. Just trace along, right, and multiply as your pencil goes across the chord. So this ends up being 4x plus 4 equals 6x minus 12. So then you get 16 equals 2x, x equals 8. And that's just all run-of-the-mill algebra. Always coming in hot. All right, let's see, I've used those 2. Now it's purple time. Hey, classic. Find the area of a hexagon with a side length of 10 inches. Again, you do not need to draw the shape. I'm going to because a hexagon is a little easier. If it were a more difficult shape, though, you really only need this triangle. Okay, let's see. We have a side length of 10 inches. you wouldn't even really need to draw this hexagon. You just need to draw the triangle that we're going to be using to find the area. I think this is the angle that's easiest to find. And always with these, trying to find the height of that triangle so that we can find the area of the triangle, which will then in turn give us the area. If we multiply it by how many of those triangles there will be, in this case there's going to be 6 of them. Since there's 6 sides, if we take the area of that triangle times 6, we'll get the area of our entire hexagon. And to find the area of a triangle, we need that height. So we're going to have to use what we know about angles. Let's see, this angle, all of the 6 triangles together, all of these angles will be 360. So if we divide that by 6, we'll get a nice 60-degree angle there in the middle. And then, so our triangle will look like this. Okay, we've got our 60-degree angle up here, 10, our right angle. Half of this is going to be 30 degrees. That makes this a 30, 60, 90 triangle. This is something that we had gone over a couple chapters ago, the 30, 60, 90 triangle. It follows a really nice rule. If I pull this over here, I'm gonna look at our right triangle. This now becomes 5. All right, we're just talking about, I'm talking about this half. Ooh, let me use my colors. I'm just talking about this right triangle right here, right? That's where this comes from. Okay, and now I've got 30 degrees, that's half of that 60, 60. This is my X in this case. This is a 30, 60, 90 triangle. 30, 60, 90 triangles will always follow this pattern. Okay, whatever your shortest leg is, if you multiply it by the square root of 3, that's going to be your longest leg. So we don't even need to use tangent for this one. You still can do the tangent of 30 equals 5 over x if you want to, but we don't need to. We can just use that shortcut. So one of those triangles is going to be, and in this case, our height now is 5 times the square root of 3. Right? We're taking that shortest leg times the square root of 3. So our triangle is going to be 10 times 5 times the square root of 3 over 2, which is, and 5 times the square root of 3 is 8.66. If you don't believe me, give it a try yourself, but you should believe me. And then this ends up being 43.3. So that's the area of one triangle, right? Doing base times height divided by 2. But we actually have, since this is a hexagon, we have 6 of those. So we just need to do that 43.3 times 6, giving us a total of 259.8 inches squared. All right, stay tuned for page number 2.